to be recorded, please contact us. And I will now leave the floor for Pete Smith to start the webinar, and I will see you later in the panel discussion. Thank you very much.
Thank you, Mohammed. Well, I don't have very much to do today. I'm just going to introduce Sarah, who's going to talk to us for about 20 minutes. So Sarah, over to you, and you can share your screen when you're ready.
All right, I'll do that. I have some difficulties with Thailand. Where is it? Yeah. Okay. My actual computer doesn't work at the moment, so I really feel stupid. This one, yeah. Okay, that looks good to me at the moment. I hope you can see now the presentation.
Perfect, thank you. Yeah.
Super cool. Okay, today I want to talk about a systematic map on CDR. And I will start with briefly saying something about what are systematic maps, basically. What's this idea of synthesis of evidence? Then I will go into the work I've done so far, and then I will give a brief outlook on that. So, synthesis of evidence, what's the idea behind it? Actually, you know about reviews and assessing information from scientific literature, but often these are not very rigorous and don't take into account all of the knowledge we have at the moment. And the idea of synthesis of evidence is to assess all available information to especially overcome a selection bias of the author. To do that, there are different protocols defined, and they all follow a similar structure, which I just outlined here on the right-hand side. Basically, how to come up with all the process and be very rigorous in searching and acknowledging all of the information systematically. These processes are very well established in defining medical guidelines. That's actually where the idea mainly comes from, or it's very well established there. And lots of Cochrane and some other institutions are very active in pushing this boundary of how to do that. It's not so much known yet in climate policy, but we want to enhance this. So we think of, or we have different types of synthesis of evidence. And I will mainly show today a systematic map. That's actually a broad overview of the existing literature on a specific topic. And it tells us what is studied, where, by whom, where are the knowledge gaps, and also where are the knowledge hubs. And these can then guide things for further research. We think of systematic map as a broad overview, a broad overlook of the existing literature. And we're talking then, because of that, of 10,000 articles at once. For example, we have already done systematic maps of climate research. And there we take only information from the abstract, so only of the overview, and more than 10,000 articles cannot be read by humans anymore, of course, and we use for that machine learning to automate processes. And I will present today the work I've done so far on CDR, on carbon dioxide removal. But once we've done that, once we've identified knowledge gaps and knowledge hubs, we can then go into a different type of synthesis of evidence, which is called systematic reviews, where we look specifically not only on specific topics, and there we also go into the full text. So we really try to extract information from the full text with specific research questions. This cannot be automated as easily as systematic maps. And that's why we have to reduce the numbers of studies and ask more specific questions. And that's also usually done by hand. Okay, now you have an idea about what's the idea, what we want to do. We go into our systematic map of carbon dioxide removal. We are here in the CDR community, and we of course know that we all the scenarios demand a rapid that we need CDR in the future. And to do so, we already know that we need an urgent need to scale up and deploy technologies. The first step to do that is, of course, research on technologies and how to incentivize and facilitate deployment of CDR, basically how to govern CDR deployment on CDR in general. And also, what does the public think about that? And all those things are also looked at from the research perspective, and of course, these give important perspectives. And a systematic map is now, of course, the idea, where are we at the research in CDR? And what is studied, where, and who does it study? Who does study it? As I told you, we followed a specific protocol, and I just go now through the different steps so you get an idea how we made sure that we gather the complete information on CDR. It's not the complete, I mean, it's a process, but as most as we can get it. So we start with specific queries with keywords describing each CDR technology. Here we see, for example, the beginning of the biochar query. And we let those queries run on Web of Science and Scopus or on a different open source database for scientific research or research in general. It's called OpenAlex. But from Web of Science and Scopus, we gather 70,000 papers after deduplication. Not all of these 70,000 papers are, 70,000 papers cannot be read by humans. Of course, you need to go then to an automation step. And we use, as I already said, extensively machine learning methods for that. Machine learning is basically you train a model to duplicate human decisions. And what we do is we let people, in our case, 6 students, very nice people, read title and abstracts of about 6,000 documents. And they had to sort them into different categories. And these categories are then used, and documents are then used to train a machine learning model, in this case, a pre-trained climate bird. And this climate bird can then be used to predict the categories to the unassumed documents. It's very standard procedure in machine learning. And we can now use these machine learning algorithms to look at the data, at the documents. Not all of the 70,000 papers are, of course, on CDR, so we have to first sort them between relevant and non-relevant. And we end up with about 29,000 documents on CDR relevant. And then we add some specific categories, like what is this document, on which CDR technology is this document. Here I just gave some of the classes categories we have, for example, afforestation, facts, blue carbon, but of course, facts, all the, you will see how many we had. Then we also looked at which scientific method do they use in their paper, basically. So, for example, is it an experimental laboratory study, or is it a life cycle assessment? Is it a review? Is it, we are also, of course, have a specific label for a systematic review, all the things. So also a bunch of different scientific methods, what you can read from the abstract. And then we have a third main category where we ask, from which angle does this paper look at? So does it especially look at the try to improve the technology, or does it investigate governmental aspect or public perception or ethics and all of these? So also here more categories than I've shown. And then we also can use additional data from the abstract or also from metadata. For example, we extract locations automatically from title and abstracts, but also we can, of course, use the affiliations and some other metadata to get as much information from the, we've never touched the full text, but we looked only at title abstract and metadata from Web of Science or Scopus. Okay, now that we collected as much data as we could with on our 29,000 documents on CDR, we now look at the data. What does it tell us? What is this CDR map about? And first we see, okay, the CDR research does grow massively, and in fact it grows faster than the CDR, the climate change literature as a whole. You see here can you see when I show it, can you see that? Okay, I hope so. So my mouse key, well.
Yes, we can see your cursor.
Perfect, yeah. Perfect, the cursor, yeah, exactly. So we see exponential growth. These are the numbers which had to take into account into the assessment cycles by the IPCC. And you see also here, of course, the numbers grows. Further, we of course have a distinction between the different CDR technologies. And here to read the graph a little bit more easy, because we have lots of different colors, I made a simplified legend. Basically, greenish is all the storage and biomaterial and land, and geological storage is those things, BECCS and DACCS. And we see from 2010, we see massive growth on biochar. Basically, mainly the exponential growth is mainly driven by growth in biochar. Okay. And here we have more than 50% on biochar in this year's. Okay, next we ask, where do the studies come from? And we use the first author affiliation as a proxy for the origin of the study, basically. And we see most of the studies come from China. Second most come from the US. Here, that's the third most country, the country with the third most studies. And of course, we see also very blue, Europe is very blue, Africa is has very little. Also, the South American is comparatively little. But I have to say here, these are only studies which I found with my search method, and I only use keywords in English. And it might be that also for Russia and also South America, which has a different language context, they might study in it. They might publish also in different languages, and we might miss there a certain percentage. And we don't know yet how many. We want to look at that further. Okay, but we see many come from China. Europe is well covered, US. And then we asked on which technologies do they mainly focus. And we see China, especially Asia, but especially China, focuses heavily on research on biochar. Oceania focuses on blue carbon, not so surprising because they have potential in mangrove reforestation, for example. And South America has afforestation, and North America is mainly ducks. Okay. Then next we asked, how much is the location-based research for North? And we derive location-based research so we say it's location-based research if they mention a location in title or abstract. So then they say, okay, we did some studies in this area, and of course, location, if you consider specific characteristics of the location, you can of course identify more specifically the potentials in these areas. And we see this location-based research is predominantly done for nature-based solutions, not to mention afforestation and agroforestry, and even blue carbon. Most of those studies do focus on location-based research. It's missing for more novel CDR options, for example, ducks and BECs, rather compared to the others. There we also need, of course, considerations of storage site and all the things, which storage sites are more suitable. And also, ducks is high energy intensive thing. Where can we produce energy best? Next, we look at we compare the papers of my CDR map, which are also mentioned in the recent IPCC report. And of course, we don't see all of them. I mean, nobody can cite them all. But we see 473 papers are also mentioned in the IPCC report, but the focus is very different. So the predominant role of biochar is missing. We have a large focus on BECs, probably because the BECs plays a predominant role in scenario literature, also called general literature CDR, where often discussions on CDR governance and public perceptions are happening. And basically the same content, but from a different angle, can be seen when you look at the main focus of the paper. We see here most of the papers of those things study the technology in itself and try to improve those technologies, or try to look at the side effects and all things. And this focus here shifts to socioeconomic pathways and policy and governance. Okay, and last, what I want to show you is the different share of CDR methods for different indicators. So, for example, I mean, here is the scientific literature that I talked about just from my map, but we got different data from the State of CDR report, the recent one, the first edition, and we see the current deployment does not look at ducks. I mean, we have 1% here, which is novel CDR, but most of them is afforestation. Patterns focuses on the new technologies, BECs and ducks. And also the scenarios do not capture biochar at the moment. They are not implemented in this scenario yet. I know it's going to change, but at the moment we don't see that yet. Okay, that's so far for the CDR map. And I will now give a brief outlook. Of course, I talked about the CDR living map of CDR research, and we've seen that I used heavily automation step. And these automation step, of course, can then be used to give regular updates. And we want to go into this direction and call this living map. So this CDR map is then regularly updated. And a first step has been done so far. So we have all the data is available at the moment on a literature hub, where you can select those papers, and every dot here represents a paper. You can access it here. Tim Varadke, my colleague, did a very nice job to do this, and it's already online. You can go there and have a look. It's in a pretty, it's not yet completely done, but you can get an idea what's going to happen. And the second outlook is, so of course, I mean, this was what I gave. It's just a brief, and it's an overview on the whole literature, but of course, we need to go more into the details and see what potentials are there. And the idea is, I mean, we already saw lots of literature out there. So there is potential for self-thematic reviews, and we want to here in our at the MCC we want to guide a share collective, we call it an ecosystem of systematic reviews, and we have a shared structure, shared definitions. For that we go into different, so we look at different CDR options: afforestation, improved forest management, soil carbon sequestration, BECCS, biochar, enhanced weathering, and ocean alkalization, ducks for carbon, and durable storage products. These are the CDR options we cover. We've found experts who lead for each of the CDR methods, experts which lead a team to do the systematic reviews. To also, I mean, they know what to do, and they know all the different entities with the CDR methods. We founded the scientific steering committee to have to guide them through the systematic review process, but also to have the same structure everywhere, so a harmonized approach, a harmonized structure and harmonized review approach. And we will then have for each of the different methods a literature systematic review which covers those topics, different topics. The first results will be given or will be presented at the Negative Emissions Conference at the panel on Friday 21st. I hope some of you will be there and listen to us. And with that, I want to conclude. So I just gave you a brief overview what I did on the system. So I gave you the idea of the systematic map, what it's about, and showed you the systematic map of CDR. We saw exponential growth in the literature, which is mainly driven by growth and biochar. Oops, biochar twice because it's exponentially. And we saw knowledge gaps probably in the global south, at least an English literature and location-based literature and novel methods. And I showed you two outlooks. We want to go into living maps and an ecosystem for reviews. With that, I'd like to thank you. And I think the questions are taken after that. Aren't they? Thank you.
Thank you, Sarah. Thank you for the excellent talk. I have a question. You know, you rely on English literature. how that will affect your result, you know. And for me, it seems like, you know, the uncertainty in the result must be a bit high. What do you say about that?
Can you repeat the question? I didn't get it really.
You rely on English literature only. So
On scientific literature
including
only.
other language
Yeah,
literature.
yes.
How that affects the result, you know?
Yes, I know. I mean, we've seen that we don't cover Africa and South America not so well. And if we can assume, at least for South America, that they also publish in Spanish or in Portuguese, because they have a large community probably within already there. And we just, I mean, if I say we have a knowledge gap in South America, it has to take with a sort of grain of salt. But at the moment, I cannot say more. And we want to look at, I mean, what you need to do is look specifically, translate your queries into the language and use this scientific terms which they use over there. And I don't feel comfortable to do that at the moment. So my Spanish is little. But of course, we try to do this, and also with other topics might be easier, where the technical terms
Thank
not
you.
so difficult.
I don't see other question in the chat. No questions. So now we are moving to the next session. We are privileged to have an esteemed panel of experts joining us today to discuss and share their insights on various aspects of this topic. So the time will be 5 minutes slot for each one. And first we have Professor Pete Smith, Professor of Soil and Global Change at the University of Aberdeen. And Pete will provide us with invaluable perspectives on land-based CDR. Please go ahead, Pete.
Yeah, thanks, Mohammed. So I probably won't take my full 5 minutes, but just to put it in context, what we're doing. So Mohammed and I, as part of the UPTAKE project, are looking at land-based methods of CDR removal. So what Sarah has presented will be invaluable to us in gathering the evidence for all of the different land-based CDR techniques. So that's one aspect that where we're interacting with Sarah. And the other aspect is that we're involved in the soil carbon sequestration review, which is one of the subsets of the reviews. In the last slide that Sarah showed, we're doing the soil carbon sequestration part. So that's still a challenge. We got a presentation at the same meeting that Sarah mentioned in Oxford, and we don't have any results yet. So it's one of these occasions where you submit the abstract months in advance, you think you're going to get finished, and we won't have many results to present. So we're going to present maybe some of the systematic review that we did for the last assessment, and just to give an update about how far we've got on. So just looking at what Sarah presented, for the land-based options, it was surprising. Well, firstly, how many papers we have to review for the different land-based options. A huge amount of work there. So it's great that we've got all these teams doing different things for the different reviews, all the experts for that, for each different carbon dioxide removal, the land-based carbon dioxide removal technologies. And the other thing that struck me is when we were looking at the location-based studies, nearly all of those with a high proportion of land location-based studies are the land-based ones. So the afforestation, soil carbon sequestration, peatland restoration, all those tend to be location-based. The good thing about that is we're going to get some really specific data where we can tie it down to a location. We can look at carbon sequestration rates or carbon dioxide removal rates in different areas. What's going to be more difficult about it, I think, is that they are very location specific. So it's going to be without some form of modelling or trying to work out relationships between soil type, climate, and other factors that vary regionally. It will be difficult to get generic numbers. So that's why our approach in uptake is going to be some systematic review to gather evidence, which is going to be complemented by process-based modelling. So I think it's fantastic work, and it's great to see how our which I regard as quite a big chunk of work to do, but in the context of the overall CDR landscape, I can see that we're just a few small cogs in the landscape, and it's really great to see where it fits in. So I'll leave it there, Mohammed, and I'll hand over, I think, to Sabine next, to give her reflections.
Thank you, Bit, for the overview. Next, we'll hear from Professor Sabine Fuss, co-chair of MCC and head of the working group Sustainable Resource Management and Global Change. Sabine will enlighten us about the broader CDR portfolio. The floor is yours, Sabine.
Yes, thanks very much for the kind introduction, Mohammed, and thanks to Sarah for giving this excellent intro. And as Pete was just covering, basically the land-related CDR options a little bit more, saying what kind of advances we would like to make in the uptake project as well. And as part of these review efforts, my task is more to put things into a little bit broader perspective. And basically, what you've seen in Sarah's presentation was that when it comes to the international assessments, IPCC, and also other review products, you actually see that you cover a lot of the literature that concerns bioenergy combined with CCS, BECCS, but also the kind of general scenario literature, the socioeconomic pathways and so on, even though they're not really the big proportion of the whole literature when we look at the full literature body that Sarah was picking apart. So that also, of course, hangs together, right? So the integrated assessment models that have been behind generating those pathways that we use then in those assessments and for deliberation started out with having bioenergy combined with CCS and also afforestation, reforestation. And there's been a lot of debate around that when it comes to what are the effects of basically scaling CDR in terms of just those two options, right? We need a lot of resources, not only in terms of the water requirements and fertilizers, but also specifically in terms of the land that we would need to set aside to grow the biomass for BECCS, to grow more forests or to reforest previously deforested areas. And that's why IAMs, so integrated assessment models, have started to take up some of the other options. So, for instance, directly filtering CO2 out of the ambient air and storing that geologically. And that also pertains to a second set of concerns with these land-based options. And this second set concerns issues around permanence and reversibility, right? Because we are already seeing climate impact taking place. And that means, for instance, if you have increased disturbances like wildfires, droughts, insect pests, and so on, then the CO2 can also quickly be released again that was previously bound in the biomass that was grown in terms of vegetation or also biomass for that. So that means that a more resilient CDR portfolio would also take into account those other options that IAMs are increasingly incorporating into them right now. And for that, actually, the ecosystem of reviews is very helpful because it extracts the knowledge that we have on those different technologies and CDR methods in order to enable not only discussion at the science policy interface about those different options, but also, for instance, for the modeling community to be able to take that up. So this is really at the heart of the Uptake project, where we take basically insights from Sarah's work, complement with insights, filling some of the knowledge gaps she identified within Uptake, and then synthesizing that knowledge in order to feed it on into the models, enabling here a whole suite of IAM models to come up with a broader portfolio. And Detlef will in a second go a little bit more into how this is done and what the expectations are, because the project is actually just started. But before I give it over to Detlef, I also wanted to say that in another work package of uptake, we're also looking actually actively now into the policies. So stepping away into the knowledge that we have on what are the potentials of the technologies, what are the costs, the side effects of scaling them, but also into how do we actually implement these? How do we achieve the scales that we actually see that we need in the scenarios that stabilize at levels, temperature levels that are consistent with the Paris climate goals? And here we actually have to realize that all of those options that I've been briefly presenting here do come with their respective bottlenecks. The land-related ones, of course, with a big land footprint. But if we talk about direct air carbon capture and storage, this takes up a lot of energy, of course. And this energy has to be produced in a carbon-free way in the first instance, and there has to be a lot of it. Now, if we have a portfolio that relies to a large extent on ducts, what does that mean for energy prices? And what does that mean for poorer households whose energy portion is quite a big chunk of the household bill? So also these kind of things have to be taken into account. While the debate in the past has been more around the environmental side effects, I think it's important to be able to integrate these options into models to say what it actually means for distributional things as well, for energy prices, for food prices, and so on, so that we can then actually in this other work package and uptake come up with policy packages that don't only come with the right incentive scheme to upscale CDR, but that can also regulate the side effects and that come up with the right governance architecture to regulate whatever comes up in terms of external effects. So with that, I think I hopefully paved the way for Detlef's contribution, and I'll say thank you for your attention. And you're on mute, Detlef.
Yeah, she's back.
You're muted, Detlef. Yeah,
and
okay.
I'm not anymore, so thank you. Yeah, so my name is Detlef Van Vuuren. I'm a part of the UPTAKE project and working with the integrated assessment modeling community. Yeah, the presentation was obviously really interesting, and one thing that was very noticeable was this very large difference between the focus of most of the CDR research and where the integrated assessment models are looking at, and which was, for instance, reflected in the chart, the graph that was shown on the IPCC focus and which articles are cited. So there are a few important lessons from this presentation for IAM research and in general, and specifically also for the work in uptake. Yeah, so first of all, it's clear that the integrated assessment models so far have focused strongly on bioenergy CCS, on afforestation, and to some degree on ducts. And there were good reasons for that. And when the models started to work on the issue of CDR, these options were seen as having a relatively large potential. And also the models had something to offer. They already had energy systems, they had land use systems, and they could nicely dynamically indicate how BECCS and afforestation should interact with the energy system and on the land use system, for instance, in relation to scarcity of land. For some of the other options, the IAMs simply have much less to offer. But as the IAM scenario results are also going to be interpreted as strategies to respond to climate change, and the fact that some of these options are not there now makes it important to also starting including them. And that's one of the things that we will be doing in uptake. In uptake, we have work packages where we look on the technical potential of these options. And after that, we will spend time trying to build them into the IAMs. the second issue one issue that I would like to stress here is that the fact that the literature looks to so much other options doesn't necessarily say, obviously, that the potential for these options is as directly related to the size of the literature. And so the fact that most of the literature looks at biochar doesn't automatically mean that the potential for CDR for biochar is much larger than the other options. And the second option that and that is we will take on in UPTAKE is that IAMs have in the past mostly been focused at what is a cost-effective way to reach climate goals. And that means that cost played a major role in selecting technologies. And as a result, also the model chooses quite a bit of CDR. And so if we have seen scenario results of IAMs, we see that up to maybe even 10 gigatons per year, or even sometimes higher, of CDR is used in achieving goals, which also allows some of the models to have quite a bit of fossil fuels still being part of the solution. There's quite a bit of discussion about this. Is cost the right metric in choosing in these options? Should risks of failure not be being taken more into account? The fact that we might go on embark on a strategy where in a few years' time or in a few decades we would find out that this was not the way to go, and that might be something that we have to build better into the models. What was already raised by Sabine in relation to that is the permanency of some of these CDR options. But also the climate consequences of overshoot. If we would have a strategy where we rely heavily on CDR options to bring us back to the 1.5 degree, that does mean that for some time we have a climate change that is higher than 1.5 degrees, with all consequences in terms of climate impacts, even for those CDR options. And some of the land-based CDR options are obviously influenced by climate. And so trying to bring in more considerations than cost alone, and therefore potentially limit the potential of CDR, might be another important issue that we need to take into account more in the IAM literature. The other thing that we will be doing in UPTAKE is to pay more attention to implementation. And what are the policy instruments that are available to implement some of the CDR options? And those might be different for the different options that we're in the review. It might be that afforestation is more easily implementable than some of the other options. And so thinking a little bit about how can we in the real world implement these policy options, what policy instruments are available, and how, for instance, also build up systems that account for the credits of CDR. How are they distributed? Are they among the regions? For instance, if you think of bioenergy, is it accounted for in the country growing the crop, or the country that does the CCS? But that can also be thought about in different sectors. And so in UPTAKE, we will spend more time on implementation and see also how that can be then translated into the IAM choices. Because that is the final thing that we will be doing in UPTAKE. And once we have got better information on the potential and cost of different options and their potential side effects, once we have brought that into the models, once we have also taken account of these policy instruments and how to potentially design policies to support CDR, we will develop new scenarios. And those will look into the role of the CDR and potentially look into, for instance, how they can ensure that we reduce emissions faster, how we can reach net zero, but also potentially how they can play a role in the second half of the century to come back after overshoot. And so these new UPTAKE scenarios, I think, will provide a better overview of the role of CDR, and this overview was already helpful to think a little bit about how that could look like. Thank you. Back to you, Chair.
Thank you, Detlef. I can't see Mohammed yet, so I'll take it from here until Mohammed's back on. Ah, here he is.
Thanks, Detlef. Thank you very much for sharing the knowledge with us. Sabine, do you want to come back or you are done? Sabine, do you want to come back?
No, I think we're done, Mohammed. We could take questions now. There aren't any questions in the Q&A box, but people could raise their hands if they wanted to ask a question live, and we can unmute them. Are there any questions?
I don't see any question in the Q&A.
No, I don't see any hands raised.
No.
Maybe in the meantime, I can ask a question to Detlef because I'm interested. I mean, you mentioned that you were also going to look more into how a CDR portfolio would perform under an overshoot scenario, which I think is very interesting. But equally, I was thinking, are you also thinking about looking into how a CDR portfolio would perform under lower CO2 concentration levels? Because I mean, I'm just thinking about in the end of the century or maybe even beyond, maybe like not so much CO2 will be taken up by vegetation anymore, and maybe that is another reason why we would need a more diversified CDR portfolio.
I can see the point of this diversification here as well. So some options obviously are not so dependent on CO2 fertilization, for instance. So we could look at the long-term role of CDR options in uptake. We haven't thought about it so far, but I think it's an interesting question.
Got a question in the question and answers, Mohammed, if you want to read that out.
Maybe my question to Sarah, do we have any idea why biochar is so dominant in the CDR literature as a whole compared to other options?
Yes, we do have a very good idea, but it is mainly because biochar has a very strong benefit when it comes to agricultural use, and it's used as fertilizer or as soil amendment. And there are a lot of studies on different types of biochar, to which crop, in which soil they work best and all things. So they really look at the agricultural aspects of usage of biochar. But of course, if you put it into the ground, and it is basically CDR. It's a little bit degraded, but it still stays as often as carbon in the ground and contributes to the whole.
The question from Sahel is about the biochar question again. Why is that predominantly in China, do you think, Sarah? Why are most of the studies in China?
I don't really know why they focus. Maybe they have an interest in that, or we know about their publishing practices, that they might publish a lot and we're just not as productive as them. But they obviously focus on this topic a little bit more than others. Yeah,
I think
also maybe because I cannot really tell actually. They have maybe also have lots of land.
Yeah, I don't know either, but it could be that there is that because of the air quality issues, the rice straw and the cereal straw used to be burned, but that's very bad for air quality, so that's been banned in China. So it could be that they're looking for other opportunities to improve their soil, the amount of carbon that's going back into the soil, and also do something with this resource that just used to be burned and emitted to the atmosphere. So that's probably one of the reasons why China is so big in this area.
I may have a. Oh, sorry, Abdallah, Mohammed, please. Sorry.
I just want to know if this dominance of of biochar has any effect on understanding the global CDR effort, particularly in terms of technological focus, geographical distribution, potential implication for sustainable development goals. Is there any effect?
Yeah, I mean, how close are we? Maybe we could phrase that to Detlef. How close are we to getting biochar represented in IAMs?
Mm-hmm.
Yeah, so I think it is most useful in models that have some representation also of land. And so either we worked with DGVMs, which might first of all do some runs, which then can be used as marginal abatement cut curves in specific IAMs, or some of the IAMs do have a coupling to DGVMs. Yeah, so for us, there are quite a few open questions, but that's simply because we are not so well coupled to the biochar literature. So what is the impact on yields? I've heard different stories here. So the potentially positive impacts, others are less optimistic. We would be interested in where it's always allowed. There is maybe some rules that might prevent biochar use at some places. And obviously, we can model ourselves nicely the energy consequences of biochar use, of the biochar production. Some of the models might have a challenge of bringing back, combining then the land and energy modeling. Some of the models have separate energy and land components. For biochar, you might want to couple them pretty much. So that might be a challenge. But yeah, I think in principle, these are challenges that can be overcome. And so within the uptake period, I expect many of the models to at least say something on biochar.
I have a question maybe to the whole panel. And this is something I've been thinking a lot about, looking at the policy sphere. And there's a lot of debate now about net zero strategies. How do we get to net zero and what have you? But there's relatively little that is more planned out in detail for going to net negative, right? And I mean, Detlef was mentioning how close we are for looking at an overshoot. And I'm sometimes wondering, I mean, we're not scaling yet. So, and then we also have sustainability constraints and all sorts of things. So in the end, what we will have at our disposal in the medium term in terms of potential that we can tap in to have CDR, we may actually then need to get to net zero. And then, I don't know, I sometimes feel that maybe we need to prioritize some of this scarce potential to steer back from an overshoot, given that some of the impacts may actually be irreversible. I don't know how you guys feel about that, or whether I'm a little bit over concerned. But I feel there's a little bit of a blind spot in the debate.
Yeah, maybe slightly related to this, in the context of the models, we can determine somewhat an optimal strategy of CDR, and we can limit CDR. But in reality, there's obviously a huge concern among people whether we use CDR potentially also to slow down the fossil fuel phase out. And so our choices on how we're going to use CDR, for instance, even saying we're now going to try and make the going fast to net zero or something like that, will also in the societal debate be interpreted also in the context of how fast do we move away from fossil fuels and what role do CDR play in that context. And so if we would say that we are mostly using CDR to come back after an overshoot, and then it doesn't sound so much as an possible trade-off with fossil fuels, as if we're saying, yeah, we also using CDR to go to net zero, for instance, where people might be more concerned. It doesn't mean that we next have to explain that it still would help CDR to go down fast to net zero and things like that, but they're just pointing out that in addition to the science way of looking at this, there is also a societal way of looking at CDR.
I see no questions in the Q&A, so
we could end it a little early, I think, Mohammed.
yeah, I think so. Yeah. At the end of this webinar, I would like to extend my gratitude to Dr. Sarah Lück for her excellent talk, and to the panelists, Professor Peter Smith, Professor Sabine Fuss, and Professor Detlef Van Vuuren for their valuable contribution and insights. And I also thank you to our audience for their participation and engagement. Please feel free to reach out with our panelists through email and continue the discussion. Thank you for all of you to joining this wonderful webinar, and have a nice day further. Thank you very much. See you there.